Welcome to Pale Blue Dot Narrative. This week, discover how artificial intelligence is revolutionizing bird conservation, giving us new tools to understand and protect avian life. Then, journey into deep space as astronomers detect possible biosignatures on a distant Hycean planet, sparking fresh questions about life beyond Earth. Finally, explore how the powerful Pacific climate patterns of El Niño and La Niña shape the health and diversity of our oceans. Let's unravel the stories that connect our planet, its inhabitants, and the universe beyond. Welcome to Tech Threads, where we explore the fascinating world of technology. Today, we're diving into the world of avian conservation and the incredible impact of artificial intelligence. For years, the work of monitoring bird populations and understanding their complex behaviors was a labor-intensive task, demanding countless hours of fieldwork and painstaking manual analysis. But now, AI is stepping up, offering us tools with unprecedented speed, accuracy, and the ability to analyze massive datasets that were once beyond our reach. One of AI's most significant contributions is in bird identification and monitoring. Deep learning models trained on vast libraries of bird images and sounds are now powering applications like Merlin Bird ID and BirdNet. These tools can identify species from a simple photograph or audio recording with incredible accuracy, sometimes exceeding 99%. This technology is not only a game changer for seasoned ornithologists, but is also empowering citizen scientists, generating a wealth of data on bird distribution and abundance. The ability of AI to rapidly and accurately identify birds from audio and visual data is a game changer. It allows us to analyze data from remote monitoring stations and citizen science platforms at a scale that was simply not feasible before. This provides critical insights into population trends and habitat use. But AI's role doesn't stop at identification. It's also proving invaluable in mitigating threats to birds. Take, for example, the issue of collisions with human-made structures. Many cities, including Toronto, have implemented lights-out campaigns during peak migration seasons to reduce this hazard. And AI is playing a crucial role in optimizing these efforts. For example, the Cornell Lab of Ornithology's Birdcast project uses AI to analyze weather radar data, providing nightly estimates of bird migration traffic over specific cities. This information allows cities to target their lights-out campaigns more effectively, reducing energy waste while maximizing protection for migrating birds. AI is also revolutionizing habitat conservation and management. By analyzing satellite imagery and other geospatial data, AI algorithms can map and assess the quality of bird habitats, detect threats like deforestation and urbanization, and monitor changes over time. This information allows for more targeted and effective conservation interventions. And in a particularly promising application, AI is helping to mitigate the impact of wind farms. Systems can now detect approaching birds in real time, identify their species, and trigger temporary shutdowns of turbines, drastically reducing bird fatalities. Early results show collision reductions of over 85% in some installations, offering a crucial solution for the sustainable expansion of renewable energy. Furthermore, AI is deepening our understanding of bird behavior and ecology. By analyzing data from tracking devices and ecological datasets, AI models can uncover intricate migration patterns, species interactions, and the impacts of climate change on avian populations. This knowledge is essential for developing effective conservation strategies in a rapidly changing world. The impact of AI extends to public engagement. User-friendly AI-powered identification tools are making birdwatching more accessible, fostering a greater appreciation for avian biodiversity and encouraging participation in citizen science initiatives. The vast amounts of data contributed by the public can then be efficiently analyzed by AI, turning individual observations into valuable scientific insights. We're seeing exciting examples of AI in action around the world. In Australia, researchers are using AI to analyze decades of archived sound recordings to identify the subtle calls of endangered woodland birds. The Cornell Lab of Ornithology's Birdcast project is using AI to analyze weather radar data, providing nightly estimates of bird migration traffic over cities like Toronto. And at Palmyra Atoll, AI analysis of drone imagery led to the rediscovery of seabird species not seen in the area for decades. While the potential of AI in bird conservation is immense, experts emphasize that it's a tool that complements rather than replaces traditional conservation methods and the crucial expertise of ornithologists. The accuracy and effectiveness of AI models depend heavily on the quality and quantity of the data used for training. As AI technology continues to advance, its role in understanding and protecting the world's birdlife is only expected to grow, offering a beacon of hope for avian conservation in the 21st century. It's clear that AI is a powerful force for good in the world of bird conservation, and we are excited to see what the future holds. In the next segment of the podcast, Cosmic Conversations, where we delve into the latest discoveries and debates shaping our understanding of the universe. Today, we're exploring an exciting new frontier in the search for life beyond Earth. Hycean planets. These are a recently proposed class of exoplanets that could dramatically expand our view of what makes a world habitable. Unlike Earth, which is covered in continents and wrapped in a nitrogen-oxygen atmosphere, Hycean planets are ocean worlds, vast, deep seas stretching across the entire surface, all beneath thick, hydrogen-rich atmospheres. These planets can be up to 2.5 times the size of Earth, and their atmospheres extend much farther into space, making them easier to study with our most advanced telescopes. One of the main differences between hydrogen-rich atmospheres and Earth's is their composition and structure. Earth's atmosphere is dominated by nitrogen and oxygen, but Hycean planets are enveloped in molecular hydrogen. This makes their atmospheres lighter, more expansive, and much puffier than what we're used to here at home. For astronomers, this is a big advantage. It means that when a Hycean planet passes in front of its star, starlight filters through a much larger volume of atmosphere, making it easier to detect what chemicals are present. And that brings us to a breakthrough discovery, the exoplanet K2-18b. Orbiting a red dwarf star about 120 light-years away, K2-18b has become a focal point for Hycean planet research. Using the James Webb Space Telescope, astronomers have detected methane, carbon dioxide, and a faint but tantalizing signal of dimethyl sulfide, or DMS. On Earth, DMS is almost exclusively produced by marine life. Its presence on K2-18b could be a sign of biological activity, though scientists are careful to point out that more data is needed to rule out non-biological sources. The James Webb Space Telescope has been instrumental in these discoveries. Its advanced spectroscopic instruments allow researchers to analyze the chemical makeup of exoplanet atmospheres in unprecedented detail. This means we can now search for biosignatures, chemical fingerprints of life in environments very different from our own. But as always in science, caution is key. While the detection of potential biosignatures like DMS is incredibly exciting, alternative explanations must be thoroughly investigated. Non-biological processes could also produce some of these molecules, and further observations will be crucial in confirming their origins. What's clear is that the discovery of Hycean planets has energized the scientific community. These ocean worlds, with their unique hydrogen-rich atmospheres, may not only be habitable, but could also make the detection of life's chemical signatures more straightforward than on Earth-like planets. As more observations come in, and our techniques improve, Hycean planets like K2-18b will be at the forefront of the search for life beyond our solar system. If we do find definitive signs of life on one of these distant ocean worlds, it will transform our understanding of habitability and our place in the cosmos. In the last segment, Eco Insights, where we uncover the science behind the natural world and their impact on our planet, we're diving into the fascinating world of El Niño and La Niña, two powerful climate phenomena that shape not only our weather, but also the health of our oceans and the creatures that call them home. El Niño and La Niña are opposite phases of a natural cycle known as the El Niño Southern Oscillation, or ENSO. This cycle originates in the tropical Pacific Ocean and has ripple effects across the globe. But what exactly are these phenomena, and how do they differ? El Niño is the warm phase of the cycle. During El Niño, sea surface temperatures in the central and eastern Pacific rise above average. This warming disrupts the normal flow of trade winds, which weakens or even reverses them. As a result, the usual upwelling of cold, nutrient-rich water from the ocean depths is suppressed. Without this upwelling, the surface waters become nutrient poor, leading to a dramatic decline in phytoplankton, the tiny organisms that form the base of the marine food web. This nutrient shortage has profound consequences for marine life. Fish populations dwindle as their food supply vanishes, and larger predators such as tuna, sea turtles, seabirds, and sharks are forced to migrate in search of better feeding grounds. Entire marine ecosystems can be reshaped, and commercial fisheries often suffer steep declines. For example, fisheries off the coast of South America, like the Peruvian anchoveta fishery, can experience massive drops in catch as fish either move away or their numbers plummet. Even apex predators like sharks are affected, as changes in prey abundance and distribution force them to adapt their hunting strategies or relocate, sometimes altering the entire balance of marine habitats. On the other hand, La Niña is the cool phase of the ENSO cycle. During La Niña, sea surface temperatures in the central and eastern Pacific drop below average. Trade winds strengthen, pushing warm surface waters further west and enhancing the upwelling of cold, nutrient-rich water along the Pacific coast. This surge of nutrients fuels phytoplankton blooms, which support larger populations of fish and, in turn, attract a wealth of marine predators. Cold water species thrive, and overall marine productivity increases. However, even during La Niña, changes in ocean currents and temperatures can shift where certain species are found, sometimes affecting the availability of prey for top predators, like sharks. The differences between El Niño and La Niña are clear. El Niño brings warmer waters, reduced nutrients, and often a decline in marine life, while La Niña brings cooler waters, more nutrients, and a boost in ocean productivity. Both phenomena, however, can trigger dramatic shifts in the distribution and abundance of marine species, reshaping entire ecosystems and impacting the people who depend on the oceans for their livelihoods. Looking ahead to 2025, climate scientists predict that ENSO-neutral conditions will dominate for most of the year. This means that neither El Niño nor La Niña is expected to have a strong influence on global weather or ocean patterns through the spring and summer. However, there is a moderate chance that La Niña could return toward the end of 2025. As a result, marine life and fisheries are likely to experience more stable conditions compared to years with strong El Niño or La Niña events, but ongoing. Monitoring remains important as the year progresses. Understanding El Niño and La Niña is crucial, not just for predicting the weather, but for managing fisheries, conserving marine biodiversity, and preparing coastal communities for the changes these powerful climate cycles bring. As our climate continues to change, the effects of these natural oscillations may become even more pronounced, making scientific research and awareness more important than ever. As we wrap up this week's journey through the wonders of science and technology, let's take a moment to reflect on the threads that connect us, from the delicate flight of birds overhead to the mysterious signals drifting through the cosmos and the powerful ocean currents shaping life on Earth. Each story is a reminder that our world is both fragile and resilient, and that curiosity and innovation can lead us toward a deeper understanding of our place in the universe. For deeper analysis and ongoing updates on these stories and more, be sure to check out our news publication, Pale Blue Dot Narratives, available on Substack and Patreon. Your support there helps keep this exploration of science and technology thriving. Thank you for joining us on this exploration. Stay curious, stay inspired, and remember, every discovery, no matter how small, brings us closer to unraveling the extraordinary narrative of our pale blue dot. Until next time, keep looking up and keep listening for the stories that connect us all.